at ionic compound formulas. So our learning intentions are to explore ionic bonding, ionic formulae, and characteristics of ionic compounds. So, when writing ionic compound formulae, the chemical formula is basically a way of representing a compound using symbols for the atoms present and numbers to show how many atoms of each element is present. For the exam, you need to know how to write the formulae of ionic compounds for the first 36 elements. Now, ionic compounds are usually formed between group 16 and group 17, which may be referred to by some of you as group 6 or group 7, and these are non-metals, and these combine with group 1 and group 2, which are metals. Now, metals have a tendency to lose electrons, while non-metals have a tendency to gain electrons. So that means that the metals will have a positive charge and the non-metals will have a negative charge because they're gaining those negative electrons. Now, an ionic compound is neutral overall, so that basically means the number of electrons lost must be equal to the number of electrons gained. So let's look at a few examples of how to form ionic compounds. So let's take an easy example to start with, potassium bromide. So the first thing you always do is write down the ion of each of the elements that you're dealing with. So the potassium ion has a positive charge, and it is K+, and the bromide ion has a minus charge, Br-. And that is mainly gotten from potassium being in group 1 and bromine being in group 7 or group 17, whichever you refer to it as. So if we want these to bond together, we can see that the K+ and the Br-, if they go together, the plus and the minus cancel each other out and leave no spare charges. So that would mean that your formula is KBr. Next, let's look at calcium chloride. So we know that the calcium ion has a 2+ charge to give us Ca2+, and the chloride has a minus charge to give us Cl-. And that comes from calcium being in group 2 and chlorine being in group 7 or group 17. Now, if we were to put the calcium and the chlorine together, we would see we would have a spare positive charge. So what we need to do is we need to get an extra negative charge. And that negative charge will come from getting an extra Cl- for our ionic bonding. So CaCl2 is therefore the correct formula for the ionic compound, because every calcium ion needs 2 chlorines in order for the charge to balance out. And this is a similar idea for sodium sulfide, which has a formula of Na2S. Another example is aluminium oxide, and aluminium oxide has a 3+ charge, so it's Al3+, and the oxide ion has a charge of 2-. So if we put the Al3+ and the O2-, that leaves us with a spare positive charge. So in order to balance out the plus and the minus charges, we actually need 2 aluminiums, which will give me 6+, coming from 2 by the 3+. And we need 3 oxygens, giving me a charge of 6-, and that's coming from the 3 by the 2-. So when you put those together, then we say that the chemical formula for aluminium oxide is Al2O3, and that Al2 is coming from the need to have 2 aluminiums to have a +6 charge, O3 coming from the need for 3 oxide ions to form our 6- to balance out the 6+ from the aluminium. This slide here shows us the group ions, and this table needs to be learned off by heart. They're very common ions that come up, with the first 4 having a negative charge, the second 5 having a -2 charge, and then the second last one having a -3 charge, and the last one having a +4. So these need to be learned by heart. Now, many ionic compounds contain some of the group ions from the previous slide, and these charges cannot be predicted, so they must be learned by heart, as I've said already. So let's do a few examples. So the first one here is potassium hydroxide, and we know that the potassium ion has a +1 charge, giving us K+, and the hydroxide ion, that's a group ion, and I will have learned that that is an OH- charge. So if we put the K+ and the OH- together, that leaves no spare charges, indicating that KOH is the correct formula for the ionic compound of potassium hydroxide. Another example is calcium hydrocarbonate. Now, I know that the calcium is a positively charged ion with a charge of 2+. The hydrocarbonate ion, as you will have learned from your group ions table, has a negative charge, so it's HCO3-. If we put the Ca2+ and the HCO3- together, that leaves us with a spare positive charge. So to get rid of that spare positive charge, we need an extra HCO3 to balance it out. So that gives me that the chemical formula of calcium hydroxide is CaHCO3-2, where the second HCO3 is needed to balance out the 2+ of the calcium. So that's it for this video. Have a read over the learning intention to make sure